Hey guys, it's Cory here with Venom Outdoors. In this video, we're going to be talking about our design process from start to finish when we come out with a brand new design. We're going to be focusing on the 221 Flutter Spoon. Alright, most of you out there are already fully aware that we have some unique products and we design those products ourselves in-house. We design our own tooling to manufacture these products. We machine our own tooling. For our design, we use SolidWorks 3D modeling software, and that works in a 3D platform. So we can actually see the product before it's even in our hands and get a very good idea of what the product is going to look like and also act like in the real world. Now, when it comes to solid modeling, there's basically two different types. Standard solid modeling, which is mainly square blocks with holes in it, simple shapes. And then there's what's called surface modeling for more complex shapes. Now, when it comes to a manufacturing machine, let's say, it's more concerning that the machine works as it should and that you can get that design done more rapidly. So that is where solid modeling is pretty much always used. If you see the pictures of our CNC machine, you're not worried about airflow, aerodynamics, or any of that over the machine. So it's mainly square shapes. When it comes to consumer products or automobiles and that kind of thing, that's where the complex shapes come into play, and that's when surface modeling comes into play, and we'll talk about both of those different things. So speaking a little bit about solid modeling here's a real good example. This is actually an air manifold. And as you can see, pretty much all of the cuts on this are just squares. So it's a square block with chunks of it cut out that are different cutters on the CNC are going to take away from that block of aluminum to give us a final part. Very simple part. So this is a surface model that I drew up in just a couple of minutes here. It's not drawn the way that I would typically draw a surface model, but it's a good example. So we can add zebra stripes to it to see what the flow is like on this. If this was a car body, once again, we could go into a little more detail to see how the air is going to act over it. And then with our real view graphics, we kind of get the mirror image of it given the plane that it was drawn on. But that gives you a better idea of surface modeling. And when we rotate or orbit that view, we can actually see how the reflections act on each of the surfaces and how smooth that transition is. So it's for very complex shapes. So the surface body as we see it right now is zero thickness. It is basically just a skin that goes around showing us a shape. And if we wanted to make this a solid body, we would have to fill in these two sides and then thicken that to give it an actual dimension. So now it would become a solid. So that's the way that those kinds of things are designed up as far as cars and that sort of thing goes. So when we start a design, basically we start with a piece of paper and a sketch or sketches. And then we take pictures of those sketches and we load those into the CAM software so we can sketch with the software around that shape. Then we have to think about design intent, the way that we're going to manufacture that product. What are the cutters that are going to be used for the actual machining of the steel? Will they fit in those small radiuses that we add? Shrink rate on plastics, draft angle on plastics for the tool design. Will the part come across with the moving side of your tool? Paint buildup on your metal components for finishing. All of these things are very important. They have to be accounted for. Another big one is your split rings. You always want that split ring to recover after you install it. So you have to think about that paint build, do testing on that to make sure that your split rings fit correctly. All of these details get very extensive, but it's a lot of fun to do. We'll show you some of those details right now. Alright, so we have a section view right here of the 221 Flutter Spoon. We're going to zoom in real close here and look at the frame. So we talked about the paint build. Right here we have an actual gap between the frame and the actual parts themselves, and that is the allowance for the paint build. So when we shoot these with powder, that will burn up this gap, and then my part is going to sit exactly where the CAD model shows, plus or minus maybe 1,000, maybe 2,000. So that gives you an idea there of the paint build that I had mentioned. We have the rattle ball inside here, it's cut in half, so we get to see that with the section view as well. And inside of here, we're going to go back to a normal view. The software sees in straight lines, so it's not as easy to see, but these do have draft on them. So when your tool is being built, you have the correct draft in there to be able to eject these parts. Also, we do have the draft and the correct draft that we need on the actual outside of the part to achieve that ejection with your tool as well. Once again, we talked about split rings down here. So what we do is we offset these faces to find out what that paint build is going to be. And then we test that gap to make sure that split rings recover, so you guys get a great product when you buy that product after it's built. So this is the master model that the 221 was designed from. Now you'll see that this model is a little bit more boring. And the reason for that is essentially in one part model, we have 3 different solid bodies. We have one solid body back here, we have one on the front, and then we have the main frame there. And then what we do is we're able to utilize that frame to draw the front and the back infernal glow parts. So the model, the models, if you will, the 3 different solid bodies that are in here are driven off of each other. So those models are essentially all in one, and then we extract that data out to separate parts, and then we build the assembly as a complete model with the radiuses on the edges of the holes, and we add these details later. One thing I'll point out as well is you see the parting line right there of the frame for that tool, and we have draft coming out of both sides of that. So even though the frame is a metal component, it is a die-cast part that too has to have all of those details in there to make sure that that part is manufacturable. So talking a little bit more in depth about the design intent for the 221 Flutter Spoon. Basically, we want the Flutter Spoon to come down in a horizontal fashion and use the viscosity of the water to get that fluttering motion. So what we set out with this is the center of mass, we want that down farther. So there's equations in this design that drive that center of mass down, and it gives us essentially the shape of a skydiver's body. Now, the first time I jumped out of an airplane, I got yelled at because I didn't arch enough, so this is pretty much burned into my head. So we get that heavier section down to keep that a predictable placement in the water. And once again, then we rely on that water to give it the action going back and forth to make it more natural looking. So hopefully this video is giving you a good idea of how we design our products. Guys, these softwares, these 3D softwares are very powerful. They allow you to do a lot of very cool things. They take very powerful computers to drive them doing these things. But it does give you an idea of how we design our products. So approximately 20 years ago, I was working on a software called Pro-E. It's a very, very powerful software. And that software had the capability of even telling you shapes that were not machinable or not manufacturable. But with today's manufacturing styles, 3D printers and that kind of thing, those warnings that it gave you are now obsolete. So those softwares don't do that anymore. It's very neat what these softwares do. It's very fun to work with these softwares with these complex shapes. Now, coming up in the next video, we're going to be talking about the actual tool design or tools that we build to make the parts that give you the products that you buy. We design those tools, and then we use Mastercam, the cam software, to program those parts for the CNC machine to cut the actual steel. So it's some pretty cool stuff. Pay good attention to the videos that are coming out. We think you'll enjoy those. As always, guys, we appreciate your business. We love each and every one of you. We hope that you come back to watch the next video.